This video will help us understand the pillars of object-oriented programming and how each of these is used in writing computer programs. Let's start by defining the word object-oriented programming. So when we say object-oriented programming, it is a paradigm based on the concept of objects. This object can contain data, which are usually in the form of fields, and codes, which usually in the form of methods. Using OOP will enable developer to easily reuse the codes by other parts of the program or even by other developers. Here are the four pillars of OOP. First one is inheritance, second is encapsulation, the third one is polymorphism, and the last is abstraction. We will discuss each of these and present some example for each pillar. Inheritance. Inheritance is a mechanism where a class can derive or imitate from another class. And when this happens, they share a set of attributes and methods. A derived class is also called child class. This is the class that inherits from another class. And base class is also known as parent class, is the class that is being inherited from. So the following codes are the example for inheritance. We have here the definition of class for animal. And then the second one is a definition of another class named cat. So cat here was derived from the base class named animal. So this is the base class, and the cat here is the derived class. From the animal base class, we have a property, or also known as variable, called habitat, and it has a value of land. And then we have a method named walk, and if this method is called, it will display a text on the screen saying walking. And on the definition of our class cat, we have a property or a variable name called family, which is a value of feline. And we have also a method here named speak, that when this method is called, it will print a text on the screen showing meow. On the main class of our program, under the main method, we created a variable out of the cat class. So this my cat variable becomes the object, an object from the cat class. After that, we call the method walk, but the walk method was defined from the base class. Even though that we use the cat class, and since it inherits from the animal, we will be able to inherit the walk method. That is why calling the walk method is a valid call. And then the second method is the speak. The speak method was defined in the derived class. And then we have a console write line printing the variable name habitat that was defined under the base class. And again, even though we use the cat class for our myCat object, we can still make use of the habitat because our cat class inherits from the animal. And then the last line here, we print the text contained in the family variable, which was defined in the derived class. So that's how an inheritance works. We have a base class, and then we have or a derived class, and all those method and properties defined in the base class will become available on the derived class, just like the habitat and the walk method. It will all be available at the derived class. Encapsulation. Encapsulation, it is an idea of wrapping the data and methods into a single unit using classes. Let's have some examples of this. This is an example of a class. So in the main method, we have created an object here out of the user class. But at this moment, we don't know the definition of the user class. And then after that, we wrote here Suresh Dasari for the name of our my user object, and Haider Rabad for location of our my user object. And then after that, we wrote some text showing the name and the value of the name, location, and then the value of the location, and then instructing the user to press key to exit. Now let's look on the definition of the user class. So on this side, we have here the class user with two variables and with two properties. So the variables are location and name. These variables are also called fields. And then we have two properties, and these are location in capital letter and name in capital letter. So inside of the location property, we have here the getter and the setter. The getter portion will return the value of the location, the field name, and the setter portion will assign a new value for our field name. For our name property, we have the same pattern. We have the getter and setter. The get portion will return the value of our name field, and then the set portion will assign a value to our name field. So using this class, we'll be able to hide the definition of these properties and fields. And after defining my user object out of user class, we'll be able to use the properties of our my user object, such as name and location. But we don't know how this name and location were created because they are all encapsulated using the class user. So encapsulation meaning wrapping around all the details into one single unit, just like this one. Class user contains this definition, but after using it, it hides all those information. And what you have here is just the properties, such as the name and the location. Polymorphism, it means that having many forms. An object or a class that can have a different form is called polymorphism. So let's see some examples of this. On this example, we have a definition of a class called animal, and it has a virtual method named speak. We have another class here that inherits from animal, and it has a definition of speak, the same with the speak of our base class, the animal. So base class, the animal, has a speak method, and the cat class, which is a derived class from the animal, has also a speak method. And we have another class here named dog, which is also a derived class from animal class, contains also another method, the speak method, which is similar to cat class and animal class. Now observe these methods, the speak for a base class, speak method for cat class, and speak method for dog class. Although they have the same method name, but they show different output. The speak method of the base class will print animal make sound, and the speak method of the cat class will display meow. But for the speak method of the dog class, it will display woof woof. They have the same method, but they have different forms. So this is an example of polymorphism. Let's move on. The last one is abstraction. Abstraction is a way of hiding certain details and only shows essential information to the user. This can be achieved with the use of abstract classes or interfaces. So these are the examples for abstraction. If we want to make an abstract class, we have to start with the keyword abstract, followed by the class name. And then we have to use also the abstract keyword for the methods that we want to make it as abstract. An abstract class cannot be created using the new keyword. Instead, it can only be used in inheritance, such as this one. We have a cat class and we inherited the animal class. Another example, we have a dog class and it inherits from the abstract class, which is the animal. And then inside of our main class that contains our main method, we created my cat object out of cat class, my dog object out of the dog class, and we call the speak method of the my cat object, and it will show meow, and the speak method of the my dog object will also display woof woof. But basically, we cannot create an object out of animal class because animal class is an abstract. So abstract class cannot create an object. Instead, it can only be used for inheritance, just like with the cat class and dog class. So that's the end of this video, and I hope that you have learned something. So see you in the next lectures.